Hi everyone, here is overview of Eclipse ASCIIE project. I've divided this video in few parts. In part 1, I will tell what ASCIIE is. In part 2, I will go through ASCIIE architecture key components. Part 3 is about software development process in ASCIIE. In part 4, I will make a demo of ASCIIE build and run. ASCIIE is an open source software platform for high performance automotive control units called ECUs, designed for safety critical systems used in autonomous drive or infotainment. Most of high-performance ECUs are doing following things. They exchange data in standardized way using some IP protocol that is used mostly for data from sensors like temperature, speed, position of the car and similar things. AVB protocol used for streaming of audio and video from cameras, for example. DLTs used for debugging data, and they are also exchanging data using DoIP that is used for UDS communication, so car diagnostics and so on. Application needs also to store data in non-volatile memory. Applications needs to be monitored for correct execution and started, terminated in fixed order. So this is what software platform does, and this is what also ASCIIE is trying to deliver. ASCIIE can run on QNX, Linux, or other kinds of POSIX systems. Project is code first, but features that are delivered have also unit test code, detailed design, and implementation linked to requirements. So software components can be qualified for example, ISO 26262. ASCIIE is licensed under Apache License 2.0. So in short, you can use it in commercial project free of charge. It is governed under Eclipse Foundation, and multiple OEMs and Tier 1 suppliers are involved. All development artifacts are available on GitHub repo, including source code, test code, development processes, release data, design discussions, and requirements. I'm recording this video at January of 2026, so we have ASCIIE 0.5 released. All components are described in details in the features webpage, where you can see what are the key functionalities of each component and what is the overall architecture. Each component has its own repository that you can access detailed designs, code, source code and test codes, and so on. One of the most important features is communication feature. It is realized by Middleware component and also some IP gateway. It is intended to manage all inter-process communication, so IPC, and also to send some IP data outside of the ECU. It's kind of an ARACOM equivalent. IPC is designed for mixed critical systems, so it supports both QM and ASIL separation. It offers very high performance, also includes zero copy. If data needs to be sent outside of ECU, then we have some IP gateway component that is currently in incubation stage. Next feature is lifecycle, realized by Middleware lifecycle, and that is used for starting applications in deterministic and in order way. Also gives the possibility to define ECU states like low power mode, degraded, in which some apps can be turned off or on. This is kind of execution manager. It also supports JSON configuration files, with slight difference that right now they are baked into binary, not as separate files running on the running target. There is also orchestration framework that gives you in-process task scheduling if you need it. There is also a persistency feature that lets you store the application data in secured way and safe way in key value storage. We have also the ITF framework for integration tests. There is also Baselibs that bundles all smaller libraries like JSON, file system support, like the operating system abstraction, some logging abstractions, and so on. ASCIIE is using Bazel as a build system that offers easy and extensible build system with remote cache possibilities that is enabling fast build times for even big projects. Software for automotive needs to be designed, written, tested, and maintained in controllable manner to fulfill functional safety standards like ISO 26262. ASCIIE project have this in mind, so we have a high quality documentation let's take a look at some of the work products that we have. Here we have a list of all the plans. So we have everything that is expected from automotive project. Let's take a look at some of those. So here we can see, for example, how implementation looks like. What are the, so this is kind of a turtle diagram, yeah. So what are the inputs and outputs of this development phase? So here we have all the detailed design description and the definition of a unit, which is nice to have. Also, what is the static view, how it's defined, what tools it is using, the same for dynamic view. Let's also take a brief look at the requirements. We click on the requirements tab. You have stakeholder requirements and software platform assumption of use, so for functional safety stuff. Let's go to the functional requirements, and here we have all the requirements for the product. So let's take a look at one of them, support of safe key value storage. We have AC level, we have status. Here we have what component is satisfying those requirements. Tax persistency, functional, okay. There is no direct link to the tests. Hopefully this will be also done in the future. So also let's take a look at the FMEA and done by for this component. So we have all the faults listed here. We have all the results of the fault. Let's take a look at the architecture view. So we have static architecture, we have dynamic architecture. So all the things that are needed, we have checklist. We have checklist for safety. So this feature looks quite complete, actually. Let's see how the verification of the components is done. So we have all the methods for the verification described, how they are done, how the interfaces tests are done, what are the KPIs for the statement branch coverage, how they understand this, how the tests are derived, a really detailed description on how the tests are done. So each release is documented, overview and what was done, so full release notes. Each component has its version. Let's go to one of them and see what is inside the release. So inside we have coverage report, binary. So this looks pretty nice and pretty complete. Unfortunately, I could not find any one place that gathers all the KPIs. Hopefully this will be also done. There is much more to explore here in the process section, but let's go to the demo part anyway. So in demo I will show you some simple setup of one of the applications from Escor. So what I did, I created a Docker container that will be our ECU that has launch manager from incubator lifecycle and has some application that is sending some IP messages over the network that is started by this launch manager. So how I did it, I cloned those two repositories from Eclipse webpage. So this some IP gateway and also this lifecycle repository. I have built application that is using vSOM IP, created a JSON that specifies the communication, so what signal on which service, what is the instance, and on which port it's sent. Yeah, and this is multicasted. So I also built this lifecycle component with Bazel. So this generated the launch manager binary. So I also created this some IP JSON that has this binary here. It specifies in which location where it is located, and it's in which group it should run. Then I compiled this configuration to the binary, and I've put everything inside Docker container. So now let's see the result. Yeah. So here I have a few consoles. This one is running TCP dump on the port to see the traffic. So now I will run my Docker container. The application for some IP started. We see the messages. Here using another console, I will just log into the container. Let's see what are the contents. So you see, let's list all the processes. So we have our launch manager. Our application is not working anymore because it's only working for a few seconds, but let me start it from the launch manager. And let me start this application using lm control call. So it was started. See, we see that this application is running, yeah, and then it will stop and transition back. So let's see also what binaries we have. So here you can see we have our SOAP client, and it should have also our JSON file that specifies the traffic, yeah. So right now there is much more that is working. For example, I could play along and also include the logging framework to have the so the application will use the middleware logging to generate the logs. From what I know, the DLTs was not working. What I know for sure is that the APC mechanisms are working. So this LoLA thingy for the low latency data exchange is working fine. So a lot to play around and test. So have fun and see you.